I just trained this model where you write some digit with text, for example 6, and then you put some image of a number, in this case 1. It's gonna add 6 plus 1, 7. There is some bug where it's repeating digits, but it knows how to calculate. So it takes text and image and it calculates, it knows what it sees. I'm using these images of digits. Let's try number 8 and some random image, which is 9. So we got 17. And this one is repeated, the first digit, that's a bug, but it's 17, it knows how to calculate. And I recorded myself making this, so now I will show you that video. I'm trying to make a roadmap for open source AI research. And I think models of future will be fully raw bytes as input and raw bytes as output. Here I have my language model. You can find this code in my video, publish your own language model. But this version in this GitHub repository that I will link below is giving directly bytes into the attention mechanism. And there is attention across every byte. So this is taking bytes directly. Now we're gonna have issues with quadratic scaling, but we will hopefully overcome attention mechanism and solve this issue of quadratic scaling of long byte sequences. But in this small model that I'm training, I have images and text. So text is converted directly into bytes and images as well. Every pixel is converted directly into bytes. So I have text images and it can generate text and images byte by byte. And it's doing attention across every single byte of full image and text. And this is the future. We don't want to compress images. We don't want to compress text, because this way we have universal lowest common denominator for all of the information, digital information. So we need to solve the attention mechanism. We need to change that, not compress images, compress text. We can compress, but then we should do it all together. So text and images together, not separate. Because neural network, we will do some kind of compression, because neural networks will learn the patterns, learn to discard unnecessary data and only keep the necessary one. But my point is we need to do it in a unified byte way, where with bytes. So it unify text, audio, video, images, everything. Good idea here is JEPA. We convert all of these bytes into latent representation, and then we predict the latent representation and then decode bytes. That's just one idea, but I see the future as in bytes unified across all of the digital data, and we need to solve transformer quadratic scaling, so overcome transformer, find a better mechanism. In this model that I'm training, unified, it's very simple. I have textual numbers, like some numbers, and then I have these digits, images of numbers. And then I combine them to just do some addition. So for example, I can put image of 5 and then plus in text, 3 in text equals, and then it can either generate 8 as image, full image, every byte. There is 700 something bytes, or just 8 single byte. So I just put my code for LLM, copy pasted from my video, publish your own LLM. And then I said, I want you to download MNIST handwritten digit and repurpose this LLM to take bytes only. So no tokens, bytes. So it will learn to add 2 numbers. One number can be byte of a number 1 to 9. And the other is the full handwritten image of bytes. Or I should say of numbers here. In full, add plus byte in between and equals byte at the end. I just realized you can't see because of my camera. So the LLM will take full byte sequence. The result will be byte sequence of the result, 2 digits. It can be one number in text, just 1 byte, and one generated digit image in full bytes, or 2 images or 2 bytes. Create this LLM, make minimal changes to the code. You need to tell this to cloud models. To accomplish this, no need for loading this current data in tokenizer. You can remove those. It's trained in 15 minutes. If we look at the loss, it stopped going down shortly after beginning. So here it stopped kind of going down. Okay, and then we have these tests, but the problem is where are images? If we take a look at our data, we have start token to be byte 253. We got 6 digit. This is byte 54. If you look at bytes, you see here, so number 54 is down here, digit 6. And we have these letters here and stuff. We have some random characters. I don't know why Apple has its own byte. What is this, Apple byte? Image has 784 bytes. Equal sign has this byte. Result bytes are empty and end token 254. So let's say we want to create 8 plus 7 equals 15. We're gonna start with 8, which is number byte 56, image 784 pixels, and resulting byte is 15, so 49 for 1 and 53 for 5. And then we have this image. This is what it looks like. Here, starting from this first 20 bytes. This zero, so these are colors. It's gonna be black in the left. And so we have star digit 8 plus byte and then image. And then at the end we have equal sign and resulting bytes and end token. Here I have an image of image 5, but if we print raw bytes as they are, this is the first 10 rows in here on the top. And you see the bytes. Now I'm thinking maybe these bytes represent different things because they represent blackness, black value. You see text bytes, they represent these actual like numbers, but image bytes represent grayscale pixel intensity. So we are feeding both and they have different meaning. But this is why we have universal AI. It's gonna take byte, it's gonna figure out the structure of this region of bytes and then learn some things, interpret it in different ways. So byte 48 might mean 0, might mean 48. Grayscale might mean something else. So if we had RGB image instead of grayscale image, then each pixel would need 3 bytes instead of 1. So 28 by 28 image would have 3 channels, red, green, blue, so 2300 something bytes. For a single red pixel at position 0, we will have 255, 00. So red is 255, the greatest intensity. Green and blue are 0, which is pure red. So this would look something like this: red, green, blue, red, green, blue, red, green, blue. So each 3 numbers per pixel. This is the question. Diffusion is for images that have continuous data. So there is infinite or almost infinite amount of different images. But there is only 200,000 tokens in vocabulary. So you use autoregressive LLMs to generate text, and you use diffusion over continuous data, continuous pixels to generate that. So what should we use for bytes? Bytes can also be continuous and discrete because bytes can depend each other, and in diffusion we are also generating bytes on the image, but in autoregressive large language models we're also generating bytes because tokens are just grouped up bytes. But then in autoregressive we take a small subset of grouped up bytes, 300,000, as opposed to infinite combinations or almost infinite combinations. And that's why we do autoregressive, because we have very small subset of possible byte groups. But in our unified model, I think we will not have any small subset of possible byte groups. We will have any subset of any way to group bytes. So this almost infinite way. But there are also ways to use autoregressive models for continuous data, or to use diffusion models for discrete data, so you can do anything. We don't want to use this. We don't want to use autoregressive for text and diffusion for images. We don't want to separate modalities. We want to have one unified framework, so we have unified modalities, so our model learns about bytes and data distribution in bytes in a unified way. So it recommends, because bytes are inherently discrete and sequential, to use autoregression, but I don't know. Because if we have image, then its bytes are gonna depend on each other. So that's or on bytes around it. So we can use diffusion there. So maybe I'll try both. Maybe we'll try different architectures for this model. For now, I'll make it simpler. I'll just put the first number to be text number, just 1 byte. Second number is the image. And the result is text number, just 1 or 2 bytes. So let it train like that for now. The training is happening. So now it's training, it's showing these outputs. Let's see what it does. Training has been finished. Let's see. I have interactive mode. Let's say 1. Enter digit. Okay, 4. Random index, let's say 1, 2, 3. Okay, so we said 4 plus 6 is what we selected, and the result is 10 expected. We got -1. It looks like we always get -1 as result, because the raw result token is 0. Let's try batch test mode. Number of tests 10. Why is it predicting nothing? Byte 0 is this null. I guess it's nothing. The model keeps just predicting 0, byte 0 with high certainty, as opposed to these other bytes that are numbers. Maybe the model is predicting 0 because images are mostly made of zeros and it's wrongfully trained to predict images, as opposed to just the result. Because we have in autoregressive models this mask where we try to predict entire sequence, train an entire sequence. But here in this case, we don't want to train to predict image bytes. We just want to train to predict the result bytes. And now Claude said it fixed it. Now model will only learn to predict the result bytes. So the way I figured it out is always predicting 0, byte 0. And I guess byte 0 is in images where it's mostly black. That's why it was learning to predict images as well, which it shouldn't do. Is loss going down? I think it is. It went from 2 to 1.7, 1.9. Okay, I hope it's gonna go down more. The loss is actually going down. 0.8, 0.75, so maybe we just need more training. There is some hope. Right now it's at least predicting actual digits, so 0, 5, 3, 4, 2. So that's good. We just need a lot more training data. There is some other bug, but I feel like this would learn 100%. It looks like this would learn if I just fix that bug. We fixed the bug. Now we have input 7 and 7 as MNIST image. So the expected result is 14. 5 plus 6, expected 11, predicted 11. So it works. Loss is 0.6, it's low. So I think it learned. If I say 3 and some digit, it's gonna be 1. So we got it's 4. So expected 4, we got 4, 4, 4. So because maybe there is some bug, but it's actually learned. If I put any number, any digit, it's always gonna guess. If I put 9, so now we got 13, it's 13 and then repeating last digit. So it actually guessed. So I feel like it just learned. Next, I wanna maybe work on a bigger model. I'm gonna do that in one of my future videos, so just check out my titles, thumbnails, and you can watch it, and see you next time.